Hello everyone, my name is Dhirender. I am from CSC D section. My roll number is 506. Now I am going to explain about Gauss-Jacobi's iteration method. This method is useful to find the roots. Now consider the system of equations a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, and a3x plus b3y plus c3z is equal to d3. Now assume that the coefficients a1, b2, c3 are diagonally dominant. Now diagonally dominant means the first equation should contain the maximum coefficient of x value. Means here a1 should be maximum among a1, a2 and a3, and in the second equation b2 should be maximum, that is y coefficient should be maximum, and in the third equation z coefficient, that is c3, should be maximum. Then these are said to be diagonally dominant. Now write the above equation as follows: x is equal to, y is equal to, and z is equal to. Now let us take the initial approximative roots as x not equal to, y not equal to, z not equal to 0. Now by Gauss-Jacobi's iterative formula we have xn plus 1, yn plus 1 and zn plus 1. This is obtained by arranging the previous equation where n is equal to 0, 1, 2, 3, so on. By keeping n is equal to 0, we obtain first approximation. By keeping n is equal to 1, we obtain second approximation root. Now put n is equal to 0. The first approximation is x1 is equal to d1 by a1, y1 is equal to d2 by a2, z1 is equal to d3 by a3. Similarly, if you put n is equal to 1, n is equal to 2, n is equal to 3 in this equation, we obtain second, third and fourth approximations simultaneously. Now continue the process until two successive approximations difference becomes negligible. Means after point we should get at least minimum 3 zeros. Now to understand better, let us solve an example. Now here is the example. Let us solve this to understand better. Now first we should check whether the given three equations are arranged in a diagonally dominant order or not. That is, the first equation should contain maximum x coefficient value, and the second equation should contain maximum y coefficient value, and in the third equation it should contain maximum z coefficient value. Now if we check this, these are diagonally dominant. Now clearly, as the above system equations are diagonally dominant, from the above equations we can write as x is equal to 1 by 8 into 13 plus y minus 2z, and y is equal to 1 by 10 into minus 17 plus 3z plus x. Now from this third equation we can write z is equal to 1 by 12 into 25 minus 2y minus 3x. Now these equations are obtained from these equations. That is, this first equation is obtained from this first equation, this y value is obtained from this second equation, and this z value is obtained from this third equation. Now take initially x not equal to, y not equal to, z not equal to 0. As we know Gauss-Jacobi's formula, therefore from Gauss-Jacobi's iteration formula, we obtain this equation. Now by using this equation we calculate the approximation roots. Now we take these equations in a calci, that is, here it is. Here a means xn plus 1 is equal to 1 by 8 into 13 plus y means yn minus m means zn. Okay. Similarly, v means yn plus 1 is equal to 1 by 10 into minus 17 plus 3 into zn plus xn is xn, and c means zn plus 1 is equal to 1 by 12 into 25 minus 2yn minus 3xn. Now let us consider this equation as equation 1. Now put n is equal to 0 in equation 1. We obtain the first approximation root. That is x1, y1 and z1. Now as we want x1, y1 and z1 values, we substitute x0, y0 and z0 values in these values. Now as here we should type the value of y0 as we want y1. The value of y0 is 0. Next, the value of z0 is 0. And similarly, the value of x0 is 0. Now we have obtained the value of x1, y1 and z1. Now these are the values of x1, y1 and z1 which we have obtained by substituting the values of x0, y0 and z0 in the calculator. Similarly, if we put n is equal to 1, we obtain second approximation root. That is x2, y2 and z2. Here, like in the previous one, as we want x2, y2 and z2 values, we should substitute the values of x1, y1 and z1 in calc. Here, in the previous we have substituted y0 as we want y1 value. Now we should substitute y1 value as we want y2 value. So, the value of y1 is minus 1.7, that is we obtain here. Similarly, the value of z1 is 2.0833. Similarly, the value of x1 is 1.625. Now we obtained the values of x2, y2 and z2. So like this, if we want nth approximation root, we should substitute the value of n minus 1th approximation root in the calculator in order to obtain the nth root. So this process is continued until we obtain the difference between two simultaneous roots. Difference is negligible. That is, after point we should get at least minimum 3 zeros. Similarly, if you put n is equal to, the third approximation roots are, now we have done up to 7th approximation. Now let us calculate the difference between the 7th approximation and 6th approximation. See, here the difference obtained between the 7th and 6th approximation roots is negligible. That is, after point we have obtained 3 zeros. Now, since the x7 and x6 approximation differences are negligible, the required values are, we can take the approximate values, that is x is equal to 1, y is equal to -1 and z is equal to 2. Now, to verify whether the options are correct or not, we can place the values of these x, y, z in the equations. That is, in these equations, if you place the value of x, y and z, we can verify it. That is, as the value of x is 1, that is 8 into 1, 8. As the value of y is -1 plus 1. As the value of z is 2, 2 into 2, 4. 8 plus 9 plus 4, which is equal to 13. So as LHS equal to RHS, hence the values of the required x, y, z is 1, -1, 2. Hence obtained. Thank you.